Okay, we have a binding energy per nucleon question here. And so we're given the atomic mass in AMU. We're also given the mass of each hydrogen atom, so a proton and an electron. And then the mass of a neutron. And so what we're going to start out doing is, okay, well, first, what is iron? Iron 56, we look at the periodic table, iron is 26. So we have iron 26, 56. So we have 30 neutrons and 26 protons. So I'm going to say times 1.0078 and times 1.0087. And so I got 30. .261, and then I have 26.2028. Add those up, and I get 56.4638. Now let's see the mass defect. So we have 55.9349. That difference, that mass defect, by being together in the nucleus is 0.5289 AMU. That's our mass defect. Now in class, we went this way with it, right? 5289 AMU times 931.5 MeV per AMU, and we get 492. 0.7 MeV, and then if we divide that by 56, we get 8.80 MeV per nucleon. However, this question, it asks for it in joules, not MeV. So here we could convert from MeV to joules. So I showed you that number once, 8.80 MeV. And then you could say times 1 MeV is 1.6022 times 10 to the minus 13 joules. So that would be one way to do it. The other is more traditional E equals MC squared method. And so it gives you kilograms right here. So 1 AMU, what does 1 AMU equal to? It tells you the amount of kilograms, and it tells you what a joule is equal to. Now that's meters squared over second squared, and that is what the speed of light squared is, E equals MC squared. So let's look at it more as an E equals MC squared question. And right now we're trying to find our mass. Our energy will be in joules. This will be kilograms, and then this one will be meters per second squared. So first thing we do is find our mass. And so we'll say our 0.5289 AMU times, there is 1.66 times 10 to the minus 27 kilograms per AMU. 0.5289 times 1.66 e to the negative 27, and we get 8.78 times 10 to the minus 28 kilograms. So our energy is equal to 8.78 times 10 to the minus 28 times our speed of light, which is 3.0 times 10 to the 8th meters per second squared. I'm going to start with that, 3 e to the 8th squared times 8.7 e to the negative 28th. I get 7.90 times 10 to the minus 11th joules. Now, let's read it again. Calculate the binding energy per nucleon. So we just found the binding energy, so now we have to divide it by our 56. So we divide that last answer by 56 and we get 1.41 times 10 to the minus 12th, which is what same thing we would have gotten if we multiplied over here. So a little more complicated than the MEV method, but it does show us our E equals MC squared, and that's in joules. So 1.41 times 10 to the minus 12th. There we go. Doesn't seem like much, but then you say, okay, now I have a mole of this substance, you multiply it by times 10 to the 23rd, and you have a whole lot of joules, whole lot of kilojoules of energy really quick.